Hi, my name is Niall D'Costa. I'm a second year student pursuing electrical engineering from PDEU. My project idea for today is to design a completely automated foot controlled welding shield helmet. To give a bit of a background as to how I came up with this idea, I am currently part of the electronics department of Team Ragnar, which is a Formula student team of PDU. Then Team Ragnar participates in competitions such as Supra 23 and Formula Bharat. And the Formula SE competition challenges students to design, build, and race Formula style race cars while testing their engineering, teamwork, and management skills. Being part of this team, you get to learn a lot of new stuff, especially machining. And one such thing which was required was TIG welding. TIG welding stands for tungsten inert gas welding, and we use it for welding our AISI 4130 seal tubes to make the chassis, as you can see. TIG welding has a lot of advantages such as it is precise and clean, and it's also very versatile and works with a lot of materials. But one of the few disadvantages of TIG welding is that it uses a non-consumable electrode. Unlike SMAW, which uses a consumable electrode, this one does not have a consumable electrode, so it requires dual hand operation. Let's take a look at the procedure here where one of our teammates, Maifa, is performing TIG welding. As it is clearly visible, one of his hand is used for holding the electrode and the other is holding the filler material. At the same time, he is required to close his welding shield flap before starting the process. The arc produced during TIG welding can reach temperatures exceeding the surface of the sun, and hence it is necessary to protect your eyes during the process. But the problem with using polarized shields is that apart from the arc, nothing else is visible, and at times it becomes difficult for the welder to configure his hands before starting the process. So, in order to solve this problem, I thought, why not let's design a mechanism that controls the opening and closing of the flap using a servo motor, and the welder can remotely operate it using his foot.
Okay, now coming to the circuit diagram, here we have the servo motor, an Arduino Uno, the IR receiver, IR remote, and a breadboard. Coming to the code, initially we import all the header files, and server.map server file is imported for controlling the servo motor, and additionally an integer button, int button, is declared to store the value of the button pressed on the IR remote. The next part of the code is maps the received IR codes to corresponding buttons on the remote control. Note over here that the number 1 and number 2 of remote is mapped to button 16 and button 17 respectively. The read infrared function is responsible for reading the incoming IR signals and mapping it to the button. In the setup function, the IR receiver is initialized on pin number 2 and the servo motor is initialized to pin 11. The loop function repeatedly reads the incoming IR signals, and if button 16 is pressed, the servo motor rotates to position 0, and if button 17 is pressed, it rotates to position 90. Now let's run the code and see the simulation. Initially, the servo motor comes to its home position. On pressing the button 1, it comes to angle 90, and on pressing that on number 2, it returns to its home position. So 1 is for opening it, and 2 is for closing the shield. Ideally, we'd want a single button that would control the opening and closing of the.
Okay, so now the final part of the project was to create a CAD diagram as a proof of concept for this project. So we started out by creating the welding shield helmet, and one thing to keep in mind was that welding shield helmets in itself are quite heavy. So the aim was to create a module that houses all the electronic components such as the servo motor, the IR receiver, the Arduino, and it's mounted on top of the helmet. It can be mounted using screws or could be mounted using magnetically using magnets so that it can be removed if not needed. Now, the mount will have a small opening for the shaft of the servo motor, and the servo motor will be connected to a tab which will be responsible for opening and closing of the flap. So that is basically how the mechanism is going to work. The welder will have the controller either at his foot or any other place that is feasible, or he could hand it over to someone else who is assisting him and can control the opening and closing of the flap as and when needed. The main approach to solve this problem was to create a mechanism that is hands free and thereby making the entire process a little bit easier for the person who's doing the welding. Further iterations could improve on this approach, wherein there's a mechanism which is voice controlled, or we can create a mechanism that closes the flap as soon as it detects the arc and opens it when the arc is quenched. So this is the final project, and as you can see over here, on the top of the helmet we have our module which houses all the electronic components. On the right hand side we have the shaft of the servo motor that is pointing out and is connected to the tab. The tab is basically responsible for opening and closing of the welding shield part. Thank you.